In this video, we're going to try to explain the basic concept behind VSEPR. VSEPR stands for Valence Shell Electron Pair Repulsion Theory. And in valence shell electron repulsion theory, the central atom is what we're most concerned with. And so we need to know the Lewis dot diagram of the central atom, because we're going to try to determine the number of atoms bonded to the central atom and the lone pairs attached to the central atom. Now, carbon doesn't have any lone pairs, so it has no E. But here, the carbon is going to be double bonded to oxygen, and this is its structural diagram. Here, the carbon is the A, and it's bonded to two oxygens. This will be a linear shape, and in fact, the structural diagram shows a linear shape. So for the VSEPR, you couldn't draw it like this, because it's not linear. For this molecule, again, carbon is the central atom, so it has no lone pairs, it has no E. I have a carbon double bonded to an oxygen, hydrogen, and hydrogen. This is called AX3, because the central atom is bonded to three different atoms directly. This is called trigonal planar, and I've drawn it in this three-dimensional shape where it's a flat, three-sided figure, so it's a triangle, and the carbon is at the center. Here, again, carbon is at the center, so it has no lone pairs. But here, the carbon is bonded to a hydrogen, it's bonded to another hydrogen, and another hydrogen. This is called AX4. Each of the atoms of hydrogen are my X's. This is called tetrahedral, and this is where a flat diagram doesn't really do it justice. My carbon is in the same plane as two hydrogens, but one of the hydrogens is coming towards you, and one of them is going away from you, and this is a tetrahedral shape. So it's a three-dimensional shape, whereas these are planar shapes. So they happen in the same plane. In fact, this is this is one-dimensional, this is two-dimensional, and this is three-dimensional. If I go to NH3, nitrogen, though, has a lone pair. So it's going to have my nitrogen is bonded to hydrogen, hydrogen, hydrogen. This is AX3 for the hydrogens, but because it has a lone pair, it is E. So this has got still four things bonded to the central atom, and they all repel each other, but we ignore the electrons. So instead of what I had for my methane here, I'm going to lose one of the hydrogens. It'll have a lone pair that are pushing these away from them. So my nitrogen is at the top of my pyramid, and then my hydrogens are coming, one comes towards you, one goes away from you, and this is called trigonal, as in three-sided, trigonal pyramidal. And so it's a pyramid shape, and it's three-dimensional. Water, my oxygen, has two hydrogens bonded to it, and it has two lone pairs, right? So that, two lone pairs. So that's its Lewis diagram, right? So its hydrogen is bonded to an oxygen, which is bonded to an oxygen. This is called AX2, but it has two lone pairs, remember? And so it's E2. And this is called V-shaped or bent. And what it does is, instead of having the two atoms bonded to it, it has electrons pushing those hydrogens into a V shape or a bent shape. Cl2, chlorine, has a full octet once it's been bonded to another chlorine, and this is called AX, because the central atom of chlorine is bonded to an X, but this central atom has 1, 2, 3 lone pairs. So it's AX3. This is linear because it only has two atoms to choose from. So it's actually a linear shape, and your chlorine is bonded to a chlorine like this. So those are our basic shapes in VSEPR theory, and if I can know about the general formula, I can accurately predict the shape around my central atom in my molecule. So AX2 is always linear, AX3 is trigonal planar, AX4 is tetrahedral, AX3E is trigonal pyramidal, AX2E2 is V-shaped or bent, and AXE3 is linear. We'll do more on this job and working with VSEPR shapes as we go, but that's how we assign the shape to it.